Hello everyone and welcome to class of VPC concepts. Today in our class we are going to discuss about virtual private cloud concepts. So we have various concepts. We have VPCs and subnets. It supports supported platform. We have default and non-default VPCs, accessing the internet and accessing a corporate or home network. So let's start with the very first VPCs and subnets. So, VPC is a virtual private cloud, which is a virtual network dedicated to AWS. So, here that means it is isolated area in AWS cloud. We can configure our own VPC and we can select IP address range. That means we can create a subnet. Now, what is the subnet? Subnet is basically a segment of Amazon Virtual Private Cloud IP address range. So, in this segment, we can launch EC2 instances, RDS databases, and other resources. So, we have some blocks, we call it as CIDR blocks, which are classless interdomain routing blocks. So, CIDR blocks define subnets. So, as we stated that selected AWS resources are launched into a subnet. So, user use a public subnet for resources that must be connected to internet. To protect AWS resources in each subnet, user use multiple layers of security. Now, what are the multiple layers of security that a user can use? Like we can use security groups and we can use network access control list as NACLs or ACLs. So, like AWS reserve first 4 IP address and last IP address of every subnet. So this is important that Amazon Web Services reserves first 4 IP address and last IP address of every subnet. So why it reserve first 4 IP address and last IP address of every subnet? For internal networking purposes. So after creating an Amazon Virtual Private Cloud, we can add one or more subnet in each availability zone. Subnet reside within one availability zone and it cannot span zones. That means one subnet is equal to one availability zone. This is important for examination point of view that one subnet is equal to one availability zone and it cannot span multiple zones. So this is virtual private cloud and subnet. Next concept we have supported platform. Like the original release of Amazon EC2, it supports a single and flat network and we can share that network with the customers if we have EC2 classic platform. We have other AWS account, we can launch instances into EC2 classic or a virtual private cloud. So after this state, that means accounts which are created after 4/12/2030, they support EC2 VPC only. That means not classic, we can use EC2 and virtual private cloud only mode. So what is the benefit of launching instances in a virtual private cloud instead of EC2 classic? Like we can, if we launch our instance in a virtual private cloud instead of EC2 classic, we can assign multiple IP addresses to instances. We can define network interfaces and we can attach one or more network interface to the instance. Like we can assign static private IPv4 address to the instance and we can associate IPv6 CIDR block also. That means we can assign IPv6 as well. That means we can assign multiple IP address, we can define network interfaces. We can change security group membership. We can add an additional layer of access control to the instances in the form of network access control list. We can run our instances in a single tenant hardware. We can control the outbound traffic from instances. Outbound traffic, we call it as egress filtering. So inbound traffic, ingress filtering. So these are the supported platform. That means for December 2013, We can launch our instances in a virtual private cloud, and it is giving us some benefits like we have discussed about. We can change the security group, we can have multiple IP addresses, we can use IPv6 as well. So we have default and non-default virtual private cloud. So whenever we create an AWS account, it supports EC2 VPC platform only. So that means it comes with default VPC. That means whenever we are creating an account, and if we are launching EC2 VPC platform, so we have a default virtual private cloud. So it has a default subnet in each availability zone. So a default virtual private cloud has a benefit. Now what are the benefit? Like if we discuss. So first we will discuss what is non-default VPC. Suppose when a user creates its own VPC and according to the needs it configure it. So this is non-default virtual private cloud. So subnets that are created in the non-default virtual private cloud and additional subnets like non-default subnets. Now what is the benefit of default one and non-default? Like default has certain parameters, but non-default VPC is as per our requirement. Suppose whatever our requirement, we can change the subnet, we can change the IP address, so we can make a new virtual private cloud as per our needs. And if we don't want to create a new one virtual private cloud, we have already the default virtual private cloud with our instance. Next is accessing the internet. That means user can control how to launch an instance and into a virtual private cloud access, and how we can access the resources in the cloud. So the default virtual private cloud, it includes internet gateway, and each default subnet is a public subnet. So each instance that is launched in a default subnet has a private IPv4 address and a public IPv4 address. It has both, public for internet access and private for its resources. So these instances can communicate with internet because we have an internet gateway attached. So the instance can communicate with the internet through a gateway, and we call it as internet gateway. So that means that internet gateway enables instance to connect to internet through EC2 network edge. So let's have a view like how it will access the internet. Suppose this is Amazon Web Services, and under it we have virtual private cloud VPC. We can see here this cloud is the internet, and here in between we have internet gateway. This is my EC2 instance 1 and 2. We have default subnet 1, subnet 2. So this is my VPC. Availability zones are different. We can see here maybe their region may be same. So we have one region. We have EC2 instances in different availability zone. We can see public IPv4 and private IPv4 similar here. They are attached with the help of a router. With the help of internet gateway, we are connected to the internet. We can see the destination and the target. By default, each instance that you launch in a non-default subnet has a private IPv4 but no public IPv4. That means by default, each instance that we launch in a non-default subnet, it having only private. So public IPv4 is added by the user when they launch it. These instances can communicate with one another but can't access the internet. User can enable internet access. That means in this case, we require to enable internet access launched into a non-default subnet by attaching an internet gateway to its virtual private cloud, and then we require to associate an elastic IP address with their instance. Let's see this. This is Amazon Web Services. We have a virtual private cloud. Again, availability zones are different. We have EC2 instance subnet 1, subnet 2 with router. So this is a routing table. We can see here destination. Now it can't connect to the internet. So how we require to connect to the internet? Suppose this. So we require to associate elastic IP address and an internet gateway attached to the virtual private cloud. Then only it will access the internet. Now we can see here. This is the custom route table. We can see main route table, destination and the target as well. Now here. Custom route, destination, target. Now we can define here IGWID, which is internet gateway ID. So we require to, that's why we have discussed over, that means no access to internet. So user can enable internet access for the instance launched into a non-default subnet by attaching an internet gateway to its VPC and associating an elastic IP address with an instance. That's why we have associated elastic IP address. If you see in this, we don't have any elastic IP address associated, but here we have associated elastic IP address and we have associated internet gateway with this. So, accessing network address translation device, that means NAT device, can be used to allow an instance in a virtual private cloud so that it can initiate outbound and inbound connections. It maps multiple private IP address to a single public IP address. Like user can connect to an instance in a private subnet to the internet through a NAT device. That means user can connect to the internet through a NAT device also, because this device can route traffic from an instance to a gateway and then responses back. So if we talk about that, how do we access a corporate or a home network? So Amazon Virtual Private Cloud can be connected to a corporate data center by using IPsec hardware VPN connection. So we can connect to a home network or corporate network by using IPsec hardware VPN connection. It consists of virtual private gateway which is attached to a VPC and a customer gateway located in the data center. As in our last class, we have discussed about virtual private gateway and a customer gateway. So we can connect our VPC with the help of home or corporate network by using virtual private gateway or customer gateway. Now, what is a virtual private gateway? A virtual private gateway is a VPN concentrated at Amazon side of a VPN connection, whereas a customer gateway is a physical device or any software application at side of VPN connection. We can see here accessing a corporate network router. So we require here virtual private gateway because we require to connect VPN connection, and here we have a corporate network. So we have a customer gateway attached to a corporate network. So this is basically difference. Like in accessing network internet, we are connected to the internet, whereas in this case we require to connect to the corporate network. So we require a customer gateway over here and VPN gateway over here because we have a VPN connection between the two. So here we require as a gateway ID. So this is how we can access the corporate network or a home network. Thank you so much.